Hello children, and welcome back to the session. In the last class, in the same topic, we have discussed about types of motion, that is translatory motion, rotatory motion. And then also we have moved on to uniform motion and non-uniform motion. Now we are moving ahead with what is another kind in which, of course, it's translatory, but we will extend it to the next case. Not clear? Okay, let me take an example now. Suppose if a man is traveling along a curve in a car. So he is at the beginning of the curve and slowly he moves on, he completes the curve and then he may move in a straight line path. But even at the end of the curve, you can see that the man is changing his position with respect to the surroundings. That means even though the man is moving in a curved path, he is in translatory motion. Then you may ask me, ma'am, then how should we say whether it is curved motion or in a straight line motion? Yes, you can say that if a man is moving along a straight line, it is called a linear motion. What is it called? Linear motion. If a body is moving along a curve, so now body means, in science we talk about everything to be a body. So or a car is moving along a curve, we call it to be curvilinear motion. Both come under translatory motion. So here is the example, right, for curvilinear motion. And there is a curved path here. You can see that the man initially is at point A, which is far from the tree. And now slowly he moved and he took the curve, and now right now he is at point B, very near to the tree. That means there is a change in the position of the car with respect to the surroundings. Initially it was at A, now it is at B. That means there is a change in the position, means he is in translatory motion. But how? Is he traveling in the straight line? No. He is taking up a curved path. That means the car is moving in a curved path. The driver of the car is taking the car along the curve. So we call that kind of motion as curvilinear motion. We call that to be curvilinear motion. If suppose there is a road straight as a straight way from A to B without any curve, and if the car moves in that way, that means in that path, then we say that it is having which motion? Yes, linear motion. So that means if there is a change in the position of the body along a straight line path, we call it to be linear motion. If there is change in the position of the body along a curved path, then we call it to be curvilinear motion. We call it to be curvilinear motion. So under translatory motion we have two types again. One is a linear motion and the other is a curvilinear motion. Both fall under translatory motion. Okay, so now the next one is periodic motion. You can see it here on the board, periodic motion. Now what is meant by period? Yes, in your school you have that, right? First period, second period, third period and so on. Right, what do you mean by period then? When there is a fixed duration of time for an event to take place, we call it to be a period. When there is a fixed duration of time for an event to take place, we call that to be a period, right? So now here, suppose in your school you have a duration of 40 minutes. First period will go on for 40 minutes. Suppose the English class is going on. After the end of 40 minutes, your English teacher leaves and the next subject teacher enters into your class. That means the next period started. So the session is repeated. Here the first period is one session, the second period is another one, and this is repeated in 40 minutes of duration or 40 minutes of time. And now let us come to the periodic motion. If suppose a body repeats its journey in a specific period of time, then we call it to be periodic motion. I repeat it. If a body repeats its motion or its journey in a specific interval of time, then we call it to be periodic motion. Very simply saying, we can say that it is repeated motion in fixed time intervals. It is repeated movement in fixed time intervals. It sounds very simple, right? Right. Let us see the example here. Right. This is sun, the star, depending on which we are all living. And this is Earth, our planet. You can see that this is moving in an elliptical orbit. Yeah, come on, hold on. You might be thinking that always Earth revolves around the sun in circular orbit. In the higher classes, you are going to learn that this is moving in elliptical orbit. Therefore, I drew it to be ellipse. Okay, come back to the point now. So, Earth is moving in elliptical orbit around the sun. Can anyone see me? When can Earth reach this point again once when it crosses it? Yes, 365 days. Why? Because the time period of rotation of Earth around the sun, or you can also say that it is revolving around the sun, right? And that is 365 days. Then its journey is repeated again. It crossed this point, moved along, and again it reached this point. So it repeated its journey after 365 days. That means it is under periodic motion. And can you give me another simple example? Yes, that you can see here. Clock. Inside the clock, you observe 3 hands. The shorter one is the hour's hand. A little bit longer is the minute's hand. And the one which is the longest out of the 3 is seconds hand. See, now the seconds hand here is at number 4. Now, it starts moving from here, and as it completes one rotation and again comes back to 4, how much time do you think it takes? It takes 60 seconds. It takes 60 seconds, and you know that 60 seconds is equal to 1 minute. So by the time your seconds hand completes 60 seconds here, your minute's hand will move by 1 more step. So 1 minute will be done there. Now let's come to minute's hand now. So minute's hand right now is at 3. So how much time it will take for that to come back to 3 again? 60 minutes. Yes, you're right. 60 minutes. That means for seconds hand to complete one rotation, it is taking 60 seconds, which is 1 minute. And whereas minute's hand is taking 60 minutes to complete one rotation. Both are repeating its motion. Both are repeating their journeys. But this is repeating the journey in 1 minute, whereas the minute's hand is repeating the journey in 60 minutes. Right? Did you get the point now what is meant by repeated motion? That is called as periodic motion. What is the period of motion here? 365 days. Now you may ask me, ma'am, then what is 1 day? Yes, Earth also spins about its own axis. That is what we have discussed yesterday. It takes 24 hours to move around itself. That is the period of spinning of the Earth. And this is the period of movement of Earth around the sun. Okay, and then here seconds hand. What is the period of seconds hand? Here seconds hand will finish one rotation in 1 minute, whereas minutes hand takes 60 minutes to complete one rotation. So this is called periodic motion. So here the motion is repeated. The motion is repeated. The journey or the path covered by it is again and again repeated in a specific time gap. Let's come to another example of the same repeated motion. Suppose you have a bob tied to a string and you are holding it. Okay? You can do that at your home also. Right. And then as you just give a gentle push to it, it starts moving forward. It reaches an extreme point and again it comes back to this. It won't stop here. You know it very well. And then it moves forward. That means it moves back here and again it moves in this direction. What is this movement called? In your earlier classes you have learned it to be to and fro motion. Is the repetition going on? Yes. It is also repeating the motion. But how? By changing its direction. Did you notice that? So once it is going forward and then again it's coming backward and then stretching its journey and then again changing its direction and again moving in this direction. Come to these examples. Do you find that this is changing its direction anywhere? No. Once when it starts here, it clicks in and moves in the clockwise direction. We call it to be clockwise direction. Even the minute's hand continues its journey in the same direction. But here, this is changing its direction. Even though it is repeating the motion, it is changing the direction. Thus, because of this additional point, we call it as oscillatory motion. So, in simple words, we can say it is to and fro motion. So, to and fro motion scientifically is called as oscillatory motion. To and fro motion is called oscillatory motion. This one, oscillatory motion, is periodic. So, definitely every oscillatory motion is periodic. But every periodic motion need not be oscillatory. Is that clear for you? Every periodic motion need not be oscillatory. Why? Because this is having periodic motion. This is also in periodic motion. This is also in periodic motion. But this one is also having to and fro motion. So it's repeating its motion by changing the direction. Hence it is called oscillatory motion. So we can conclude that every oscillatory motion is periodic, but every periodic motion need not be oscillatory. Okay? I'll repeat the whole thing again. So yesterday we discussed about the translatory motion. Under translatory motion again you have two types. One is linear motion. That means when a man or when a body is moving in a straight line path, we call it to be linear motion. And when a body is moving along a curved path, we call it to be curvilinear motion. Here is the example. And the next kind of motion is periodic motion. Whenever a body repeats its journey in a specific interval of time, we call it to be periodic motion. So you have seen the example of Earth moving around the sun, and you can also see that the seconds hand, minutes hand, hours hand will be moving within the clock in a specified direction and in their respective time intervals. Respective time intervals. What did you get from this? See, seconds hand is taking 1 minute to complete one rotation. To repeat its motion, it is taking 1 minute. But whereas a minute's hand is taking 60 minutes to repeat its motion. So therefore the time intervals are different. But the motion is the same kind. It is periodic. Right. And then now this is also periodic. But it is also changing its direction. It is having a special kind of motion, that is to and fro motion. To and fro motion. That is called oscillatory motion. Thus we can conclude that every oscillating body is also having periodic motion. Now, is everything clear? Yes. And now it's your job to give me 2 2 examples each: curvilinear motion, periodic motion and oscillatory motion. 3 twos are 6 examples. I'll be waiting for your answers. Thank you. See you again.